Good morning, dear students. In the last lecture, we have understood about the decrease into the vapor pressure when we add solid into the liquid. We have seen in case of decrease in the vapor pressure of solid in liquid type of solution that decrease in vapor pressure is same in case of 1 mole of sucrose or 1 mole of urea is added to 1 kilogram of water. Now, dear students, it does not matter that what substance do you add 1 mole. You can either add 1 mole of sucrose or 1 mole of urea. The decrease in the vapor pressure is same. The same is written here. Irrespective of nature of solute, decrease in vapor pressure depends upon the quantity of solute, or you can say the mole of solute. Now, mole is actually depending upon the number of species. That means 1 mole is equal to 6.022 into 10 to the power 23 species. Therefore, we can say decrease in vapor pressure depends upon the number of particles irrespective of nature of the solute. My dear student, now we are going to introduce a new term which is known as the colligative properties. Let us try to understand what is colligative property. There are some properties of solution that depends upon the total number of solute particles irrespective of nature of solute. Remember, my dear students, these are the properties of solutions, and this property depends upon the total number of particles. This property does not depend upon the nature of solute, but it simply depends upon the total number of solute particles. Such properties are called colligative properties. Now we'll try to understand the word meaning of colligative. The word colligative is taken from Latin. In colligative, co means to gather and ligare means to bind. So this is how we understand the meaning of colligative property. There are 4 colligative properties that we have to study in our syllabus. The first colligative property is known as the relative lowering of vapor pressure. My dear student, the first colligative property is relative lowering of vapor pressure. Please do not consider that vapor pressure is not a colligative property. So please remember, it is the relative lowering of vapor pressure which is a colligative property, but only vapor pressure is not a colligative property. Now we should understand the other, or we should understand the name. Second one is elevation of boiling point. Third one is depression of freezing point. Fourth one is osmotic pressure. Now we will understand all the colligative properties one by one. The first colligative property that we are going to learn is known as the relative lowering of vapor pressure. In case of a solid is added to the liquid solvent, the vapor pressure of solution, that is what it is known as the P total, is less than the vapor pressure of pure solvent. Dear student, when a solid is added to the liquid solvent, the solution is solid in liquid type of solution. The solid solute, which is not exactly the volatile substance, and that is why it does not contribute into the vapor pressure. Ultimately what happens that the solid particles also take some space on the surface and decreases the vapor pressure. This particular phenomena we have studied into the previous cases. Here vapor pressure decreases. This is known as lowering of vapor pressure. So my dear students, this phenomena that takes place when the vapor pressure of solution is less than the vapor pressure of pure solvent, this phenomena is considered as a lowering of vapor pressure. For convenience, let's take P total is equal to P. Now for this particular understanding, let us take P total is equal to P, and P0 is the vapor pressure of the pure solvent. So P0 is the vapor pressure when the solvent is available in the pure form. The decrease in vapor pressure is P0 minus P. So initially a pure solvent has vapor pressure P0. Finally the P total or this total vapor pressure of solution is taken as a P, and that is why the decrease in the vapor pressure is P0 minus P. The ratio, now we are trying to understand what is relative lowering of vapor pressure. So we are going to give the definition of relative lowering of vapor pressure. The ratio that starts from here, the ratio of decrease in the vapor pressure, that is P0 minus P, is to vapor pressure of solution is called the relative lowering of vapor pressure. Sorry my dear students, we need to change this. The ratio of decrease in vapor pressure is to vapor pressure of pure solvent. Is called the relative lowering of vapor pressure. So now we can write relative lowering of vapor pressure is equal to P0 minus P upon P0. This is how we really understand. As we are aware that in liquid type of solution, solid is non-volatile, so vapor pressure of solution is P. Depend upon the mole fraction of solvent, that is X1, because solute is solid and solvent is liquid, which is the only volatile component. So according to the Raoult's law, we can write P is equal to P0x1. Remember my dear students that this P is the total vapor pressure of a solution made by adding solid solvent into liquid solvent. P0 is the vapor pressure of pure liquid solvent, and X1 is the mole fraction of pure solvent. X1 is the mole fraction of solvent into the solution. Lowering or decrease in the vapor pressure due to adding of solute, which is non-volatile, is written as P0 minus P. We know that P is equal to P0x1. So by putting the value P0 minus P0x1, if we take P0 common, finally we get P0 into the bracket 1 minus x1. Here x1 is the mole fraction of solvent. We are aware that x1 plus x2 is equal to 1, where x2 is the mole fraction of solute, which is a solid, not volatile. Therefore, in place of 1 minus x1 from this equation, we can write x2. So here 1 minus x1, in place of 1 minus x1, we will write x2. So lowering of vapor pressure, which is P0 minus P, which is actually P0 x2, here we have just put in place of this 1 minus x1, we have written x2. So from this equation B, we can understand it very easily. Therefore, if we take this P0 on the left side, or we divide the equation, or we multiply the equation with 1 upon P0, what we get is P0 minus P divided by P0 is equal to X2, where P0 minus P upon P0 is known as the relative lowering of vapor pressure. Here X2 is the mole fraction of solute, which is non-volatile solid. From the equation C, now let us see which is the equation C. This equation is your equation C. So from this equation, C, we realize that relative lowering of vapor pressure depends upon the mole fraction of non-volatile solute particles. We are aware that mole fraction of solute is equal to X2, which is equal to N2 divided by N1 plus N2. This comes from the definition of mole fraction, where N2 is the mole fraction of solute and N1 is the mole fraction of solvent. That is what we need to remember. Moles of solute or moles of substance is equal to the mass of the substance in gram divided by molar mass of the particular substance. So for N1, we can write W1 by molecular weight 1. For N2, we can write W2 by molecular weight 2, where W1 is the mass in gram of a solvent, molecular weight 1 is the molecular weight of solvent, W2 is the molecular weight mass in gram of solute, molecular weight 2, MW2 is the molecular weight of solute. So for X2 from this equation, if we put the value of N2, N1 and N2 here, we finally get X2 is equal to W2 by molecular weight 2 divided by W1 divided by molecular weight 1 plus W2 divided by molecular weight 2. But we know that P0 minus P upon P0 is equal to X2. So instead of X2 we can write this, and finally what we get is P0 minus P divided by P0 is equal to W2 divided by molecular weight 2 divided by whole W1 divided by molecular weight 1 plus W2 divided by molecular weight 2. Now for dilute solutions, remember this we consider for the dilute solutions, moles of the solvent is much greater than the moles of solute. Mathematically we can write, or in other words we can write N2 is less than N1. Therefore N1 plus N2 is approximately N1. So we can write that, or we have this equation P0 minus P upon P0 is equal to N2 divided by N1 plus N2. Here in place of N1 plus N2 we can simply write N1. Therefore P0 minus P upon P0 is equal to N2 plus N1. Now we are aware that N2 is equal to nothing but your W2 divided by molecular weight 2. N1 is nothing but your W1 divided by molecular weight 1. Therefore, we can write P0 minus P upon P0 is equal to W2 into molecular weight 1. We know that denominator of denominator, this is denominator of denominator, denominator का denominator turns into numerator. Remember, denominator of denominator turns into numerator. So W2 multiplied by the molecular weight 1 divided by W1 into molecular weight 2. This is the equation to find out the relative lowering of vapor pressure. Remember that remember here that number 1 represents the solvent and number 2 represents the solute. Now colligative properties are generally used to calculate the molecular mass of the solute. Now here molecular mass of the solute is nothing but your molecular weight 2. So if we take molecular weight 2, if we want to find molecular weight 2 from this equation, we can write molecular weight 2 is equal to W2 into molecular weight 1 divided by W1 multiplied by relative lowering of vapor pressure. This is the final equation from which we can calculate the molecular weight 2. Please read and write the solved example that is given into your textbook, the solved example number 2.6. Please read and write in your notebook. Thank you, my dear student.